Download this code from codegive.com, link in the description below. Logging request bodies on failure in C, a comprehensive guide. When building robust and reliable C applications, especially those interacting with external services via HTTP requests, effective logging is crucial for debugging and troubleshooting. One common scenario where detailed logging becomes invaluable is when a request fails. Capturing the request body that led to the failure provides critical context for diagnosing the issue. This tutorial will guide you through the best practices for logging request bodies specifically when HTTP requests fail in C, covering important considerations and providing a practical code example using the popular libcurl library. Why log request bodies on failure? 1. Debugging HTTP errors ** HTTP status codes, 4xx, 5xx, indicate problems, but they rarely pinpoint the exact reason for the failure. The request body often contains the data that caused the server to reject the request. 2. API misuse identification * incorrectly formatted JSON or XML, missing required fields, or invalid data types in the request body are common causes of 400 series errors. Logging the body helps pinpoint these issues immediately. 3. Security vulnerability detection * by examining the request body, you can identify potential vulnerabilities, such as SQL injection attempts or cross-site scripting payloads, especially if the errors are related to input validation. 4. Reproducing errors * logging the exact request that caused the failure allows you to easily reproduce the problem locally or in a test environment for thorough analysis. 5. Audit trails and compliance * in certain regulated industries, logging request and response data is mandatory for auditing and compliance purposes. Logging the request body on failure ensures you have a complete record. Best practices for logging request bodies * 1. Conditional logging * only log the request body when a request fails, example HTTP status code equals 400 or a network error occurs. Avoid logging on success to minimize log size and potentially expose sensitive data unnecessarily. 2. Log level management * use appropriate log levels, example debug, error, warn, to control the verbosity of your logging. Log the request body at a level that is appropriate for debugging, but not so high that it fills up logs unnecessarily in production. 3. Data sanitization and masking * before logging, always sanitize or mask sensitive information within the request body, such as passwords, API keys, credit card numbers, or personally identifiable information, PII. Use techniques like redaction * replace sensitive data with placeholders like or redacted. Hashing * hash sensitive data to obscure its original value. Tokenization * replace sensitive data with a non-sensitive token. Encryption * encrypt the sensitive data before logging. Removal * completely remove sensitive fields from the logged request. 4. Error handling and robustness * make sure your logging code is robust and doesn't crash your application if it encounters errors while trying to log, example disk full, logging library issues. Use try-catch blocks or similar error handling mechanisms to gracefully handle any exceptions that might occur during the logging process. 5. Log file management * implement proper log file management practices, including log rotation * automatically rotate log files based on size or time to prevent them from growing too large. Log retention * define a retention policy for log files, example keep logs for 30 days, 90 days, etc., to comply with regulations and conserve storage space. Centralized logging * consider using a centralized logging system, example syslog, elk stack, Splunk, to aggregate logs from multiple servers and applications for easier analysis. 6. Performance considerations. Logging can impact performance, especially if you're logging large request bodies frequently. Minimize the overhead by using asynchronous logging, which writes logs in the background without blocking the main thread. Avoiding unnecessary string copying. Using an efficient logging library. 7. Clarity and context. Include relevant context in your log messages, such as timestamp, request URL, HTTP method, HTTP status code, error message, correlation ID, if applicable, application version, host name/IP address. 8. Encoding considerations. Ensure you're handling the encoding of the request body correctly. HTTP requests can use various encodings, example UTF-8, ISO 8859-1. Log the encoding along with the request body to avoid misinterpreting the data. 9. Logging libraries. Use a dedicated logging library for C, such as syslog *, a standard system logging facility, available on Unix-like systems. *splog *, a modern, header-only, very fast C++ logging library, often used with a C wrapper. *glug *, Google's logging library, used in many open-source projects. Custom logging *, you can also write your own custom logging functions, but using a well-tested library is generally recommended. Code example, using libcurl and basic logging. Explanation *. 1 includes * necessary headers for stdio.h, stlib.h, string.h, curl/curl.h, and time.h. 2 log_message * a basic logging function. In a real application, replace this with a robust logging library like splog or glug. Logs to stare for simplicity, using a formatted timestamp. 3 Write callback * a libcurl callback function to capture the server's response. It dynamically allocates memory to store the response data. It's crucial to handle memory allocation errors. 4 Mask _sensitive _data * this function attempts to mask sensitive data in the request body. This is a very basic example in a real-world application. Use a proper JSON/XML parsing library, example Janssen, libxml2, and more sophisticated masking techniques. The example shows how to mask the value in password field. A better solution would be to have a configurable list of fields to mask and apply the masking to them. 5 Main *. Initializes libcurl. Sets up the URL, request body, and headers. Sets the curl_write function and curl_write data options to capture the response using the write callback function. Performs the HTTP request using curl_easy_perform. Checks the result, res, of curl_easy_perform and the HTTP status code, HTTP_code. Logging on failure * if the request fails, either res equals curl_ok or HTTP_code equals 400, it logs the following: URL, HTTP status code, error message from libcurl, masked request body, using mask_sensitive_data, response body, captured in response_data. Cleanup * frees the allocated memory and cleans up libcurl. Compilation *. Important considerations *. Robust masking * the mask_sensitive_data function in the example is very basic. It only handles a simple JSON structure and assumes the password is in a field called password. In a real application, you'll need to use a proper JSON/XML parsing library and implement more robust masking techniques that can handle different data formats and nested structures. Consider using a configuration file to specify which fields should be masked. Error handling. The code includes basic error handling, but you should add more comprehensive error checking and handling, especially for memory allocation failures and libcurl errors. Logging library. Replace the simple log_message function with a real logging library like splog or glug. These libraries provide features like log levels, file rotation, and asynchronous logging. Content type handling. The code assumes a JSON request body. If your application sends other types of data, example XML, form data, you'll need to adapt the masking logic accordingly. Concurrency. If your application is multi-threaded, make sure your logging code is thread safe. Use mutexes or other synchronization mechanisms to protect shared resources. Legality. Be aware of privacy laws and regulations, example GDPR, CCPA, that may restrict the collection and storage of personal data. Ensure that your logging practices comply with these regulations. Consider data minimization techniques to only log what is strictly necessary. Rate limiting. If you are making a large number of requests, consider implementing rate limiting to prevent your application from being blocked by the API provider. You can log information about rate limit errors to help diagnose and resolve these issues. By following these best practices and adapting the code example to your specific needs, you can implement effective logging of request bodies on failure in your C applications, making debugging and troubleshooting much easier. Remember to prioritize data sanitization and security to protect sensitive information.